All right, part 2 of solving systems of equations with elimination. I want to remind you guys of something, which is if I had something like this, negative x equals 5, how do I find out what x is? What can I do? Okay, we would switch the sign. What am I actually doing? Like, think of that golden rule of algebra. Do you go into one side as you do into the other? Yeah. Okay, I could divide by negative 1. That's totally fine. So we could think of this as dividing by negative 1. X equals negative 5. But couldn't you also think of it as multiplying by negative 1? Because a negative times a negative would give us a positive x.
Oh.
And a negative 1 times 5 would give us a negative 5. And that's how I want to start thinking about this as we're multiplying times negative 1 to kind of clear a negative.
Right.
You'll see. So, we can multiply both sides of an equation times negative 1. What if I had an equation like this? Negative 3x minus 2y equals negative 6. Let's say we were going to graph this as a line. Wouldn't it be a lot easier if we got rid of a whole bunch of those negatives?
Yeah.
So we could multiply both sides of this times negative 1. What happens though is the distributive property, right? If I multiply this side of the equation times negative 1, I end up with 3x plus 2y and then a positive 6. So it kind of turns out multiplying by negative 1 is not a super hard thing to do. We just switch every single sign. We switch the sign of every single term. Okay? So I could give you a really complicated problem. Negative 3x plus 5y minus 7z plus 2 equals 8x minus 7y minus 3z minus 5.
Multiply by negative 1.
We can multiply both sides of this by negative 1 very quickly. All we're going to do is switch the sign of everything. So if I multiply this side times negative 1, and this side times negative 1.
The whole entire equation?
Yeah, we have to do the whole equation. What do I get over on this side? Everything times negative 1.
3x.
So we have 3x
Negative.
minus 5y plus 7z minus 2 is negative 8x plus 7y plus 3z. So we're just switching signs. Okay? This is actually a really useful trick to know about, because if you have a problem with a whole bunch of negatives, you can get rid of most of them by multiplying by negative 1. Okay? But the reason that we're going to look at this trick is for systems. So let's say we had a system of equations. Say our system of equations looked like this. 3x plus 2y equals 10, and 7x plus 2y equals 18. If I added these together, would the y's drop out?
No. Oh, you have to multiply one by negative 7.
Multiply one of these equations by negative 1. Now, which one would you choose here?
You could do
Yeah, why? I mean, there's not a wrong answer. It will work either way. But why might we want to choose the first equation?
because it's lower.
It has smaller numbers, so we'll keep our answer positive. So I would multiply this equation times negative 1. If you want, if you like, you can kind of rewrite it down here, if that makes more sense to you. Now if I added them together, those y's are nice and lined up, right? I'll get rid of them. Boom. And just like Bluebird said, we keep all our numbers positive. 4x equals 8. Divide both sides by 4. X equals 2. And I'm done, right?
Yeah.
I found x. What am I missing?
Yeah.
Y. How do I find y?
Plug it in.
Okay, where do you want me to plug it in?
Whichever one.
Doesn't matter. Can I plug it into this equation? I can actually. Because this equation is technically the same as this one. It doesn't matter. Now normally I'm going to choose an equation with a lot of positives. Just because that makes it a little easier to find. So let's just plug it into the original equation here. 3x plus 2y equals 10. If I plug in 2 for x, what do I have?
6 plus 2y.
Okay, I'm going to write it out like this though. 3 times 2, right? Which you said is 6 plus 2y equals 10. Subtract 6, right? 2y equals 4. Divide by 2. Y equals 2. 2. 2. All right. So really the only difference is what from what we've been doing?
Still multiplying negative 1.
Yeah, and that's like the very first step, right? So that multiplying by negative 1 in the very first step, that will be the only difference from the last one. Let's do one more problem. So let's say I had something like this. 3x minus 4y equals negative 4. And then
Multiply by negative 1.
yeah, will that work?
Yeah.
It will, right? Because I have both negatives now. If I make one of them positive, they'll limit.
You make the first one positive, wouldn't you?
Sure, so let's multiply this one times negative 1. So we have negative 3x plus 4y plus 4. Add those together, what do we get? Negative 3x plus 5x is 2x. Drops out, equals 0. So x equals 0. If x is 0, let's plug into this equation. 5 times 0 minus 4y equals negative 4. So we have negative 4y equals negative 4. Divide both sides. Y equals 1. So answer is 0, 1. Put it in a box, please, on your homework.
Put it in the box.
Question?